All right, welcome everyone to week 13, our live session here. So if you could give me a smiley face if you are in the room paying attention, if your audio is going through okay. One smiley face, there we go, awesome. So welcome. Today we're actually starting Unit 4. So if you still haven't taken your Unit 3 test, it's still open and available to you guys, but here's a quick note. I also posted this as an announcement today. Unit 3 is closing. What happens every unit is you guys have one whole week after the test to turn in any missing work for that unit, right? It's been the same the whole semester. So since our test was Wednesday, that means you have until next Wednesday at the end of the day to turn in any missing Unit 4 work. So just check your grade books, make sure you're not missing anything, and get it in before that deadline. Through the file transfer window, I shared with you guys some Unit 4 notes that I took. If you're here in person, you had two things to pick up today, right? Your slides to pick up and then the Unit 4 notes. The notes are awesome because I compiled all of the vocabulary words for you this unit. Plus, if you kind of flip the page, do you guys see how there's a lot of diagrams there for you too? I don't know if those of you at home have opened that yet, but it basically gives you all of your formulas in one place. That way you guys don't have to go and hunt them down when you're taking tests and quizzes. So feel free to thank me later, but I'm saving you a lot of time by giving you those notes as well. So we're going to jump in. Like I mentioned last week, we're not doing Unit 3 this week. We are jumping into Unit 4 since your test was on Wednesday, and then yesterday you had your first day of learning about chords and arcs. So today we only have about 18 slides since we're only covering one section, so it's not going to be too difficult. And here we go. So your week 13 essential question, I decided not to put it at the beginning of the session this time. Instead, I'm going to put it somewhere in the middle. This is going to ensure that students watching on YouTube are not looking for the question and then turning off my recording. These are meant to be helpful for you. They're not meant to be torturous. So you need me, even if you don't think that you need me. So please make sure you're watching the whole session. All right, picture number 1 in your diagram of your notes. Here is a basic circle. So what I'm going to ask you to do, I'm going to give you about a minute for this task. I have 4 actually, different vocabulary words up here. I have the word diameter. See how it's in blue and then my line's in blue? I know that it's not on your notes because it didn't print in color, but see how up here the word's in blue and then it shows it to you in blue. Radius is in orange and then the line's in orange. Chord is in green, the line's in green, and then the arc. I want you to take about a minute and see if you can tell me what you think their definition is. Not official math lingo definition, but just based on what the picture looks like. What would this word mean? What does this word mean? So let's take a minute and do that. Based on the students here with me in the room, we're not quite done yet, so let's take about 30 more seconds. Okay, so let's start with diameter. And again, these are not official math definitions. These are just based on our observations. What are we seeing? What are we thinking? So do I have a volunteer in the room with me for diameter? What do you think? What do you think, Daniel?
It's the length across the circle.
Yep. It's across what spot of the circle? Across the middle. Yep, so it's the line across the middle. Good job. All right. How about someone at home? Can you type in what radius is? Someone watching from home, please type in what you put down for radius. Okay, so a couple things typed in. It says a line halfway across the middle, and then the next student put halfway across the middle. So it looks like that's the consensus, and you guys are absolutely right. So it's from the middle to the edge. That's where it's going. It has to start in the middle, and it's going to the edge. Good job. Now an arc and a chord are what we're learning about today. This is Unit 4. Unit 4 is all about chords and all about arcs. So the chord I can't say that goes across the middle, right? Middle's the wrong vocabulary word because it doesn't go across the middle. What do you think, Taylor? For chord.
I think that it's a straight line that connects 2 points across the circle, and I think every diameter is a chord, but not every chord is a diameter.
Oh, he said that perfectly. My goodness. Okay, so what he said is the chord has 2 points that are on the edge of the circle. Doesn't necessarily have to go across the middle. A diameter would be considered a chord, and he's right. Diameter is a more specific word because diameter means the middle. So every diameter is automatically a chord, but then he said a chord is not necessarily a diameter. That's perfect. So chords are going to connect 2 points that touch the outside of the circle. So it's a line with 2 endpoints on the circle. Forgive my horrific writing today. And then lastly, we have an arc. So we're going to deal with arc. And what do you guys notice? Arc is the only one that is what? Curved. Yeah, it's the only one that's not a line, right? It's a curve. So you cannot call an arc a line because that's not a line. It's a curve. So next to arc, we're going to put that it is a curve. It is a portion of the outside of the circle. All right, great job. So when we get these questions in math, don't just throw them out of your brain and say, I don't know what that word is. Just a picture speaks 1,000 words, they say, right? So just based on the picture, we could come up with their definitions. So now we're going to learn 2 new vocabulary words today. If you have your notes printed out, can you underline the word central and point to the first angle? Now, if you guys have yours printed out, yours are not in color like mine. So here's what I want you to do. Can you make your central angle big and bold, please, with your pencil? Or if you have a highlighter, you could highlight it. But right now, since yours is not in color, probably, like if you're here with me, we're just going to make that central angle really big and bold with our pencil. An inscribed angle, on the other hand, is like the one on the right. Can you make that one really big and bold, please? So again, without knowing the definitions, we can pick a lot of information out of these 2 pictures. Let the words help you. You ready? Central. That sounds a lot like the word center. What kind of angle is a central angle? One that starts from the center. See? Central, center. They go together. Everybody okay with that idea? So if I had an angle that started in somewhere, well, we'll go over those in a minute. How would we describe inscribed? How could we describe this kind of an angle? It's starting at the middle. Where does it start from? What do you think, Destiny? It starts on part of the arc. It starts on the edge of the circle. Is everybody okay with that? Where's the angle at? It's on the edge of the circle. So if you want to make that note real fast, starts on the edge of the circle. Or you could say arc. Starts on the arc of the circle. So if I show you a picture of these 2 angles, would you be okay labeling them as either a central angle or an inscribed angle? They look very different. Questions, comments, concerns? You're thinking, why do I need to know this? I'll show you in just a second. There's formulas that go along with these. So here's my question. These are the same 2 pictures as the last slide, but now I'm asking you a question. It says, what do we know about angle SGM? So let's come over here. I'm showing you, first of all, how can I label my blue angle? Can you guys help me out? How do I label it? SLM. So what they're showing me in my blue, and again, since you don't have a color copy of your notes, make sure this one's really big and bold. So what's the picture showing me? SLM. Everyone okay with that? You go from the edge to the angle to the edge when you're labeling our angle. They're asking me, what do I know about SGM? So let me change colors here. SG M. Does anybody see anything that they have in common on my picture? They're both inscribed, yes. What else though? What about the arc?
Their angle is at the arc, like the point.
Their points have the same arc. Okay? Exactly. This is new vocabulary for us, so I know that I was kind of pulling that out there. They have the same arc. Even though they go to a different point on the circle, SGM has this arc. SLM has the same arc. Here's a new geometry term for you guys. If two angles have the same arc, guess what that means about their angle? It's the same angle. That's cool. That is like super cool. That tells us so much. So SLM has the same arc as SGM. If the arc is the same, these angles are the same. That's very cool. Anybody have a question about that so far? Because they're going across the circle and hitting the same amount of space across the circle. So they have the same angle. Watch what we're going to do now. Oh, I didn't put it on there. Okay. Are there any more that have the same arc that we could draw in? So I want you to think about this for a second. Are there any more that would be the same? The answer is yes. There's a lot more that would have the same arc. Can you guys please write down one or two more angles that would be the same as what you see on the screen? So let me give you about 30 seconds to do that. Find some more. It has to be the same arc. So the opposite direction if you want, but the arc portion has to be the same. So let's try a few. So the key was the arc has to be the same. Everybody okay with that idea? That means the endpoints are the same. Let's see why that's true. They both started at S, they both ended at M, right? Because that's the arc between those two. So what would be another combination that starts at S and ends at M? Let me grab a different color. Let's try that blue. S, somebody give me a letter. S, N, M. Perfect. Oops, if I could draw a straight line. S, N, M. Are there more? S, O, M. See how there's a lot of answers in there. So as long as they end up with the same arc, you are golden. They are the same angle. That's super cool. So, what about LPN and HPN? Okay, so L, P, where's P? P, what was your other one? N? L, P, N. So L, P, N would give you this arc over here. Ah, that's a good question. Okay, so let's stop right here. You are already knowing where we're going this unit. That's great. So he's saying, what about L, P, N? Is that the same arc as over here? I'm going to leave that up in the air for now because that is where we're going this unit. That is exactly where we are going. The answer is yes. The answer is yes. They are the same. So it's the same arc. Great job. So which means they'd have the same angle. Good. We haven't even gone there yet, but you're already seeing where we're headed this unit. Good job. Okay, so we are going to continue on. There's lots and lots of good answers up there. So I want to show you this picture for a second. Everybody look at B, D, C. B, D, C. What kind of angle is that? We just learned the vocabulary word. Inscribed, right? It goes to the opposite side of the triangle. What about BAC? What kind of angle is that? Central. It's in the center. So take a peek. I have both of my kinds of angles up there. I have an inscribed and I have a central. What's the relationship between those two? Don't say it out loud. Can you write something down on your paper in one sentence? What's going to be our relationship between an inscribed angle and a central angle? Write down what you see. And there was a question earlier about a central angle. Only angles that are in the very middle of your circle are central angles. Okay, Neil stated it perfectly, so I'm going to read what he wrote. He put that the central is double the other angle, and they have the same arc. They do. Okay, so let's write that down. The central angle is double the inscribed angle, and they have the same arc. Perfect, perfect observation. Which means, guess what that means? If I give you the inscribed, you can tell me this one. Am I correct? If I say that's 40, you would tell me that the central one is 80. If I tell you that the inscribed is 50, you would tell me that the central is 100. See how if I just give you one piece of the puzzle, you're going to be able to tell me a whole lot. And they have the same arc, because if we look here at angle A touches at C and B. What about D? D touches at B and C. So they still have the same arc. Awesome. Good job, guys. Questions so far? We're going to practice with you now. So if I told you, and in math, you know how they love their equations, right? Here's how you're going to see it in the book. They might call that one A. They'd call this one 2A. See how that's generic, and it will work for any kind, right? Whatever the inscribed one is, the other one is double that. Okay. All right, so try this one.
Is that only when they have the same arc?
Ah, we're going to get there. I love your questions. You're reading my mind about where we're going. Okay, so please fill in the answer on your paper. This is a quiz question. Different number, but this is a quiz question.
So how do we know the equation we set up? A equals 2. 2A equals.
Okay, so great questions. I'm hearing, how do we set up our equation? What does that look like? So before we solve, because sometimes I have students say, well, how do I know which one's A and how do I know which one's 2A? So bear with me for a second. Watch this. If I take my pointer finger and I'm looking at the 50, okay, it's kind of a skinny angle. You guys hanging in there with me? Now if I look at X in the middle, that's a fatter angle. Would you agree? Okay, my inscribed one, skinnier. My middle one, fatter. What does fatter mean? It's the bigger one. Okay, so the middle one, the middle one is always the one that's 2 times the other one. So the little one is always A, the big one is always 2A. So please type in your answer. What did you guys get for X? If A is 50, what would 2A be? Okay, great. Everybody in the room says what? 100. Great job. We okay? Hanging in there? Does my answer make sense? Yes, because when I look at these 2 angles, my inscribed angle is a skinny angle. My central angle is a fat angle. How much fatter? Twice as fat. Large. Twice as large? Probably more grammatically correct. Twice as large. Okay, how about this one? Okay, don't freak out on me. Try this one. I gave you one. I'm asking you for the other. So before we go any further, look at the 2 that we're talking about. Here's my central angle. Here's my inscribed angle. The middle one is always the larger one. So what does that mean? How am I going to find x? What did you have to do to the 102? You divided by 2. Good job. Because this is your a, and this is your 2a. So I took my 102, divided by 2, and I got 51. Take a peek at my picture real fast. Do you guys notice anything? Here's a 102, and here's a 102. My central angle is always going to be exactly the same as my arc angle. That's cool. My central angle is always exactly the same as my arc angle. Always. My inscribed angle, my angle all the way across the circle, is always half of the outside arc. So kind of some really cool relationships going on that we're going to be using all throughout Unit 4. Okay, so next, now we're going to talk about how to measure an arc. There's 2 ways to measure an arc. The first one's by degrees. This is the easy way. This is the easy one. Before I go any further, what do I know about a circle? Circles are what? 360 degrees. Everybody okay with that idea? So if I tell you that this little piece of the puzzle is 45, that means the rest of mine has to add to 360. So 45 and 315 totals 360. Pretty easy concept, right? Like when we were dealing with triangles, it was 180. Circles are 360. So we're going to try one. I'm going to give you one with some missing information, and we're going to try one. So on my first example, this says if BAC equals 60, let's put it in there. What does BPC equal? BPC equal. So take a quick second and solve that for me. I told you a piece of the puzzle. I'd like you to find the other piece that's missing. If you're at home, please type in your answer. So remember, we're talking circles, not triangles, right? So my total in my circle is 360, and I'm going to subtract from what I know, so I get 300. Are you okay with that? I want to talk about how they label things real fast. Notice with my first angle, it says BAC. That means it's going from here to here to here. So the corresponding arc is 60. When they label the other side, this is where it gets important. How are you going to show that you go around the circle the long way? I just can't say from B to C. I can't say that. Because if I said BC, I'm thinking this. Do you see what I'm saying? Can't do that. That's why they throw in that third letter. They give you a third point. So whenever we're labeling things, we always need to be using 3 letters. BPC. Now there's no confusion about which part of my arc they're talking about. Does that make sense to everybody? Can't just say BC because I'm thinking this, even though this is technically BC also. So that's why you have to use 3 letters. It tells you which direction to go around your circle. Let's try that again. Let me leave you to this one. It says if BPC is 315, what does angle BAC equal? Awesome. I have 4 perfect answers in the Dropbox area so far, comment area. 6 perfect answers. So how did we solve? 360 minus 315 gave us 45. The math is not hard this chapter. Hopefully we're feeling that way. It's really just using the circles. Okay. Next, here is your essential question for this week. We're not quite done yet. We still have a couple more to go. But my essential question, even if you're here in person, please copy this down, says what is the difference between an arc length and the measure of an arc. What's the difference between arc length and the measure of an arc? If you're at home, please give me a green check mark when you have that copied down. Let's put a star next to measure of an arc. That's what we've done the first half of class today. Okay? That was the first half of class. Arc length, that's what we're going to do this second half of class. Oops, I meant to say first half. That was first half of class. This is the second half of class today. So measure meaning what degrees is it, right? We just found out 45 degrees, 60 degrees. So now we're going to talk about how do we find arc length in just a moment. A couple people haven't given me a green check mark, but this will not be up again at the end this time. I'm sort of being a little sneakier about where I'm putting my essential questions. Okay. Isaac Grillo, you ready? Fabulous. Okay, here we go. Semicircles. What does semi mean? Well, semi actually means a portion. Yeah, so it's actually going to be the half of the circle. So he's right, it is half. What's half of a circle? 180. How else could we know that though? 360 divided by 2, right? Half of the circle. Okay, that's an easy one. Here is our arc length formula. So we're going to learn how to use this crazy formula today. And it's right here. I'm giving it to you. It says L, which stands for length, equals the measure of the angle divided by 360 times 2 pi r. So what's the difference between measure and length? It looks scary. It's not scary. I promise. No, it's not scary. Okay, so what's the difference between a measure of an angle and the length? Well, the measure of the angle is a degree. Length is a distance. Length would be if I set a string on the edge of this circle, how long is my string? Okay, so measure again is a degree. It's going to be like 45 degrees, 50 degrees. Length is going to be like 2.2 feet. So length means if you set something on the edge of the arc and you're measuring it, how long is the distance? Length is a distance. So let's try one. Here we go. What is the arc length if r is 4 meters and m is 62? On our picture, can you guys all label your picture with me? It says r is 4 and my m is 62. So I'm going to make that a degree, 62 degrees. So if we were to draw a circle with chalk, my kids love chalk, maybe you have chalk laying around at home. If I had them draw a circle that had a radius of 4 meters, that'd be kind of a big circle to draw, but that's fine. Radius of 4 meters with an angle of 62 degrees, and I wanted them to measure this with a piece of string. How long would their piece of string be? Let's find the distance. So what is length? Length is distance. We're finding the distance. So let's try. L equals m, which is 62, divided by 360 times 2 pi r. What's my r? 4. Calculators are just fine. That's why I love calculators. Okay, so watch how I'm going to type this into my calculator. Right now I have kind of this crazy fraction going on. Everybody agree with that? Watch, I'm going to make this a fraction as well. How can I make my right side a fraction? Put it over 1. So in my calculator, I'm going to multiply my whole top together, and then I'm going to divide by my bottom. So in my calculator, I'm going to type in 62 times 2 times 4, and on the bottom, I'm going to do divide by 360. I'll show you why I left pi off in just a second. Can you try that? So 62 times 2 times 4 equals, and then divide by 360. And what do you get? 1.38. I'm going to go to 2 decimal places. And I'm going to stick the pi on the end. Do you guys remember how when we were doing circles last unit, sometimes we'd leave pi at the end and sometimes we would multiply pi out? We're going to do both again. So 1.38 pi meters. Now we're going to write the word or. Or, let's take our calculator and do 1.38 times pi. To approximate pi, what number do I use? 3.14. So in a calculator, can you do 1.38 times 3.14? And you guys can use a calculator on your phone. I know all iPhones, if you swipe straight up, you get a calculator option. It's really handy, easy to find. Yeah, multiply. 4.33 meters. Good job. So if I were to have my 2 boys draw a radius of 4 meters, make an angle of 62 degrees, the circle that they would draw would have this arc length of 4.33 meters. So it's not hard math to set up, and yes, you can use a calculator. So look what I did. Does anybody have a question on why I rearranged the order? We know when we're multiplying everything together, is 3 times 2 the same as 2 times 3? The same, right? When you multiply, order doesn't matter. So that's why, since all of these things are multiplied together, I'm going to multiply my whole top together and then hit enter, divide by my whole bottom multiplied together. And you get your 2 answers. Let's try again, because again, the first time is always kind of bizarre, kind of weird. So let me give you a moment to set up your problem.
Should we ever try and simplify 85 over 3060?
Okay, great question. So the question was, should I ever try to simplify before I multiply? And the answer is, you can, but you don't have to, and you'll still get the same answer. Isn't that cool? So if you see a fraction that can be simplified, you can totally simplify it. But if you are just going to be multiplying anyway, your final answer will already be simplified. So it's up to you. When I see a fraction, and here's why we're left with meters, by the way. Because if I have degrees on top and degrees on bottom, what happens to my degree symbol, you guys, in math? If I have degrees on top, degrees on bottom, what happens to my degrees? They go away. That is why my final answer is a distance, because I'm left with, this was 12, oops, we're not in meters this time, we're doing feet. Look at my only units left in my problem. My degrees cancel, I have pi, and then I have feet. So that's how come your final answer ends up being in a distance, because your degrees go away. So if I set this up in my calculator, I can do 85 times 2 times 12. I'm going to leave the pi alone, divided by 360. So first leave the pi in your answer. Do 85 times 2 times 12 divided by 360. The key with using a calculator is to make sure you press equals after you do your top portion of your problem. So type all that in, hit your equal sign, and then divide by 360. Did anybody try it? No? But hopefully when you're at home, right, you can just pull up a calculator on the internet or your computer or whatever. So you would get 5.67 pi feet. Or, let's do my big or, 17.80 feet. I can work with you on rounding if we need help. Okay, so make sure that you guys are checking your answers at home, that when you do have a calculator in front of you that you're plugging your stuff in correctly. Okay. Are there any questions on this one? Yes. What? Yeah, we got a round. So like when you first type it in, well, they said, oh, she's asking more of us. She wants us to round. Any test or any quiz is not going to have a million decimal places listed, am I right? They just don't do that. So if I see, what was the number? Was it 5.66? What was the next number? It was another 6? Okay. So typically they'll round to 2 decimal places. Obviously you'll have to see what answer options are there for you on the quiz, but you almost always round to 2 decimal places. So what does this 6 do to that 6? Changes it to a 7. So that's how they got that answer. Good question. Why do we leave out pi until the end? So Neil, sometimes on a quiz, they're going to have your answer in pi form, meaning they're going to have 5.67 pi there as an answer choice. Sometimes they're going to multiply the pi through. So that's why I like to have you practice both ways. So that way we have them in terms of pi, and we also have it in a final decimal version. They're kind of preparing you guys for later math classes. When you get to pre-calculus, we always leave pi in our answer. So it'll make more sense when you guys get later on in math, but we never multiply the pi out in pre-calc. So it'll make more sense later, but that's why I practice both with you. So last thing today, and Giovanni hit the nail on the head at the very beginning when he pointed this out, there's a new theorem here. And this is the last thing today. It says chords and arcs theorem. In a circle, the arcs of congruent chords are congruent. So what that means is, and I know a lot of times we think, oh my gosh, there's a lot of math jargon going on there. What does that really mean? Take a peek. A chord and a chord. Everybody agree that those are chords? They go from an edge to an edge, edge to an edge. What specifically are they telling me about these chords? That they are congruent. That's what that little line means. So if I have congruent chords, what does that mean about their corresponding arc? They're the same. If the chord's the same, the arc's going to be the same. And that's what we found out in that first example this morning, kind of by default. So that means this blue part is going to match this blue part. Kind of cool. So you'll be using that this coming week. Does that make sense? If the piece of the circle is the same, the arc's going to be the same. So that's kind of what we're ending with today. We're going to jump in a little bit more next week with more Unit 4. If you missed the essential question, please make sure you go back, watch the whole recording. I'm not trying to trick you. I'm just trying to make sure that if you're at home, you've watched the whole thing when it's posted on YouTube. So thanks, guys. Have an awesome week, and I will see you next Friday.